History often mistakenly attributes the meteoric rise of the Mongol Empire solely to the composite bow and the tactical brilliance of the feigned retreat. These were merely instruments of kinetic warfare. The true strategic engine that allowed a nomadic confederation to govern the largest contiguous land empire in human history was not a weapon, but a logistical protocol, the Yam. It creates the profound historical paradox. A civilization without stone cities or permanent roads constructed the most sophisticated high-speed information superhighway the world had ever seen. Now, let's open the historical ledger and analyze the economic blueprint this crisis left behind. To understand the magnitude of the Yam system, we must first analyze the ordinary world of 12th century Eurasia, a landscape defined by the tyranny of distance and the crushing weight of friction. Before the Mongol consolidation, the economic geography of the Silk Road was not a continuous artery, but a fractured collection of isolated nodes. As we observe the topographical map on screen, note the vast gaps between the commercial hubs of Chang'an in the east, Samarkand in the center, and Constantinople in the west. In this pre-integrated system, trade and governance were shackled by latency. Information moved only as fast as a single caravan could travel, burdened by the need to carry its own supplies and the constant threat of localized predation. A message sent from the Khwarezmian borders to the Jin dynasty territories was not a stream of data. It was a perilous expedition that could take months if it arrived at all. From a systems analysis perspective, this environment was plagued by extreme information asymmetry. A merchant or a governor operating in one sector had zero visibility into market conditions or political shifts occurring 500 miles away. This uncertainty acted as a massive tax on economic throughput. Capital could not be deployed efficiently because the risk premium was too high. Governance was equally paralyzed. A centralized authority cannot effectively manage a periphery if the feedback loop, the time between issuing a command and receiving a status report, exceeds the operational tempo of the crisis. This was the logistical wall that Genghis Khan hit immediately following his initial conquests. The Mongol military machine was built on speed and maneuverability, but as the territory expanded, the administrative lag threatened to cause the empire to collapse under its own weight. The crisis was one of scalability. The inciting incident for the creation of the Yam was not a battle, but the realization that conquering territory is vastly different from holding it. The empire faced a critical choice: accept the limits of a decentralized, rating-based economy, or engineer a new infrastructure capable of compressing space and time. They chose the latter, giving rise to the Yam, or Tu in Mongolian. We must recognize that the Yam was not simply a postal service. It was the imposition of a standardized operating system over a chaotic substrate. When we analyze the initial decrees establishing the network, we see a shift from ad hoc travel to a rigorous, station-based topology. The core innovation was the decoupling of the message from the messenger's physical limits. In the previous system, the limit of transmission was the endurance of a specific horse and rider. The Yam introduced the concept of the relay. By establishing way stations at fixed intervals, roughly every 20 to 30 miles, the distance a horse could gallop at full speed without braking. The Mongols transformed the logistics curve. As shown in the comparative velocity chart now on screen, this changed the speed of information from approximately 25 miles per day, standard caravan pace, to upwards of 200 miles per day. This was an order of magnitude leap in bandwidth. However, the physical infrastructure of the stations, the barns, the hostels, the corrals, was only the hardware. The genius of the system lay in its software, the protocols of authority and resource allocation. This brings us to the introduction of the Pesa. On screen, we see examples of these metal tablets, inscribed with gold, silver, or wood depending on the rank. In economic terms, the Pesa was not merely a passport. It was a bearer instrument of unlimited credit and absolute prioritization. It digitized authority. A rider carrying a high-level pesa did not need to negotiate for fresh horses or food. The tablet commanded the resources of the local station immediately. This eliminated the transaction costs of negotiation and the friction of local resistance. The establishment of the Yam signaled the end of the ordinary world of fragmented isolation. It converted the Eurasian landmass from a series of disconnected markets into a single, high-velocity network. The call to adventure. Here is the challenge of maintaining coherence across a scale that the human mind had previously found unfathomable. The Mongols did not just build a road, they built a nervous system. As we move deeper into the analysis, we must understand that this system required immense resource extraction to maintain. It was not free. The cost of maintaining thousands of stations, tens of thousands of horses, and the grain to feed them represented a massive fiscal burden on the local populations. This tension between the efficiency of the network and the cost of its maintenance would become the central economic ordeal of the empire. The shock to the system was absolute. For the first time in history, the center could see the periphery in near real time. The ordeal in any systemic transformation is not usually the initial implementation, but the grueling reality of operational maintenance and scaling. For the Mongol Empire, the Yam system represented a radical rebalancing of the relationship between geography and governance. To understand how this network functioned as the ordeal that tested and ultimately strengthened the empire, we must deconstruct its operational mechanics. We are not looking at a road network. We are analyzing a distributed, protocol-based logistics machine. The fundamental architectural innovation of the Yam was the shift from carried logistics to cached logistics. In the previous era, a military or diplomatic mission was a self-contained unit, dragging its own supply chain behind it like a heavy anchor. This limited range and velocity. The Yam inverted this model. By pre-positioning resources, horses, fodder, food, and shelter, at fixed intervals, the network absorbed the logistical burden, allowing the packet, the messenger or official, to travel with zero friction. As we examine the schematic of a standard or two station, on screen, observe the standardization. Whether situated in the arid steppes of Mongolia, the humid river valleys of China, or the frozen forests of Russia, the functional requirements remained identical. A standard station was legally mandated to maintain a specific quota of fresh horses, often between 20 and 200, depending on the traffic density of the route, along with specific rations of grain and meat. This is where we see the rebalancing of the economic system. The Mongols imposed a command economy on top of local subsistence structures to service the network. The local population was taxed not just in silver or grain, but in service availability. They were required to maintain the station's readiness at all times. This created a continuous, decentralized supply chain where the cost of logistics was distributed across the entire population, rather than being borne by the central treasury alone. However, a network of physical stations is useless without a software protocol to manage access. This brings us back to the pesa, which we must analyze as a sophisticated authentication and authorization token. In a low-trust environment, which describes almost all of the medieval world, moving through foreign territory required constant negotiation. Every local magistrate, bridge keeper, or ferryman was a potential bottleneck, demanding bribes or verifying credentials. The pesa eliminated this latency through visual absolutism. When we analyze the legal codes of the era, specifically the Yasa, we see that the pesa did not request passage, it commanded it. A holder of a high-tier pesa, often stylized with the image of a gerfalcon, had the authority to commandeer horses, seize food, and demand fresh mounts immediately. The local station master did not need to verify the rider's identity, only the token's validity. This is a crucial distinction in systems architecture. it shifted trust from the person to the protocol. This drastically reduced the transaction time at each node. A changeover of horses, which might previously have taken hours of negotiation, could be completed in minutes. We can see the economic power of this standardization in the chart displaying message velocity versus distance. The data indicates that a priority message could travel from Karakorum to Budapest in weeks, a journey that took trade caravans a year. But the Yam was not merely for the Khan's orders. This is where the elixir begins to form. The security and reliability of the Yam infrastructure spilled over into the civilian economy, creating the phenomenon known as the Pax Mongolica. The sheer density of a station network provided a security umbrella for global trade. Because the Khans relied on trade for tax revenue, the Yam routes were aggressively patrolled. Brigandage, once a constant tax on commerce, was suppressed with extreme prejudice. For the first time, a merchant could transport a bale of silk from Hangzhou to Genoa with a reasonable expectation of safety. This rebalanced the global value equation. Before the Yam, the highest value was placed on autarky, self-sufficiency, because relying on distant suppliers was suicide. Under the Yam, the risk premium on transport collapsed. We see a surge in inter-regional specialization. The ordeal of the journey was mitigated by the infrastructure. The Yam allowed the global economy to leverage comparative advantage on a continental scale. However, we must also analyze the immense stress this system placed on the empire, the internal ordeal. The Yam was a voracious consumer of capital. As the empire matured, the distinction between official state business and private usage began to blur. We see historical record from the reign of Genghis Khan, where the system nearly collapsed under the weight of abuse. Nobles and minor officials, possessing pases, would treat the Yam stations as a free travel service, exhausting the horses and bankrupting the local populations responsible for their upkeep. The friction here was the classic tragedy of the commons. Because the cost of the fresh horse was borne by the local station, the commons, but the benefit was gained by the rider, the individual. Demand for fresh horses outstripped the biological regeneration rate of the herds. This forced a systemic correction, a rebalancing of the protocol. Mongol Khan, recognizing that the logistical backbone was fracturing, instituted rigorous audits. He recalled thousands of pases and strictly limited the Yam's use to essential imperial business. He decoupled the merchant traffic from the official traffic, requiring merchants to pay a tax for the use of the roads and stations, rather than accessing them for free. This reform is critical for our analysis. It marks the transition of the Yam from a purely military extraction machine to a sustainable public utility. The merchants paid into the system to fund the security and infrastructure they utilized. This is an early historical example of a toll network funding infrastructure maintenance. Furthermore, we must look at the information architecture that the Yam enabled. It created a centralized database of the empire. Because every envoy and official had to pass through these nodes, the central administration could track movements, harvest local intelligence, and monitor regional loyalty. The station masters were not just stable hands. They were intelligence nodes. They reported on the traffic passing through their sector. This allowed the Khans to practice management by exception. In a typical feudal system, the king is blind to the periphery until a rebellion is already underway. With the Yam, the feedback loop was tightened. If a local governor stopped supplying the Yam station, it was an immediate signal of dissent, visible to the center within days. The logistics network acted as a sensor array, detecting anomalies in the political fabric before they became existential threats. The ordeal of the Yam was the challenge of synchronization. How do you keep 100,000 horses fed and ready across 6,000 miles of varying climate? The solution was radical decentralization of operations combined with radical centralization of authority. The local communities managed the hay and the stables, operations, but the Khan managed the Pesa and the Yasa, authority. As we conclude the analysis of this phase, we see that the Yam destroyed the old world of isolated city-states. It forced the entire Eurasian landmass to operate on a single clock. The price of this speed was high. The relentless extraction of resources from the peasantry and the constant vigilance required to prevent the system from being cannibalized by corruption. But the result was a platform economy centuries ahead of its time. The Yam proved that in a large-scale system, physical assets, horses, roads, are secondary to the protocols that govern their allocation. We now arrive at the return with the elixir. Having traversed the historical landscape of the Mongol Empire, we must now transport this architectural logic into the present. The horses and way stations have dissolved into dust, but the topology of the Yam remains the governing blueprint of our modern world. When we strip away the biological components, we find that the Yam was the ancestral prototype for two of the most critical systems in the modern economy: the digital architecture of the internet and the resilience models of global logistics. The elixir we retrieve from this analysis is the framework of protocol-based decentralization. Let's first apply this to the digital realm. The fundamental challenge the Mongols faced was latency, the time delay between a request and a response across distance. Today, software engineers battle this same adversary. In systems architecture, we utilize content delivery networks, CDNs, to solve the exact problem Genghis Khan solved in the 13th century. Consider the diagram on screen. In a centralized model, every user requests data from a single origin server. This creates a bottleneck and high latency for distant users, the equivalent of a messenger riding all the way back to Karakoram for every decision. The CDN model, however, places edge servers geographically closer to the user. These servers cache, store, copies of the data, just as the Yam stations cached fresh horses and food. When you stream a video or load a web page today, you're not connecting to a server in California. You're connecting to a local node that has pre-positioned the resources you need. The Yam station was the original edge node. The lesson here is clear. To achieve speed at scale, you must decentralize the asset, the data/horse, while standardizing the protocol, the code/yasa. This brings us to the second modern parallel, authentication. Recall the Pesa, the tablet that granted immediate access to resources without negotiation. In modern cybersecurity, we utilize a nearly identical concept known as the bearer token, or JWT, JSON Web Token. In a stateless authentication system, the server does not need to constantly check a central database to verify who you are. It simply looks at the digital token you carry. Your Pesa validates its cryptographic signature, the Khan's seal, and grants access. The Mongols understood a principle that modern organizations often forget. Trust is a transaction cost. By embedding trust into a physical or digital token, you remove the friction of verification from the edge of the network. This allows independent nodes to operate autonomously but coherently. Now, let us pivot to the physical supply chain, where the lesson of the Yam serves as a warning against hyper-efficiency. For the last 40 years, the modern global economy has been obsessed with just-in-time, JIT, logistics, removing all inventory buffers to maximize capital efficiency. We treated the supply chain as a frictionless plane. However, as recent global disruptions have shown, when a single node fails, the lack of buffers causes systemic collapse. The Yam was not a just-in-time system. It was a just-in-case system. The stations maintained horses that might not be used for days, consuming grain and requiring labor. In a modern MBA classroom, this would be viewed as waste or inefficient capital deployment. But from a resilience perspective, this was the insurance premium required for survival. The elixir here is the understanding that redundancy is the price of reliability. The Mongols conquered the world because they valued throughput over cost savings. They understood that the most expensive resource is not grain or silver, but time. By investing in a surplus of logistical assets, the cash horses, they bought themselves the ability to react faster than any adversary. For the modern leader or systems architect, the application of a Yam framework is direct. If you are building a system, whether it is a corporate team, a software platform, or a logistics network, you must resist the urge to centralize every decision and minimize every cost. Instead, standardize the protocol. Create clear, rigid rules for how resources are accessed, the YASA. Decentralize the cache. Place the resources and decision-making power as close to the edge of the network as possible, the station. Tokenize authority. Give your operators the PESA, the pre-approved authority to act without seeking permission for every move. The Yam proves that the strongest systems are those that combine the rigid spine of central authority with the flexible limbs of local autonomy. As we close the ledger on the Mongol Yam, we're left with a profound realization about the nature of power. We often associate empire with the static grandeur of stone walls and throne rooms. But the Mongol genius revealed that true power is kinetic. It is the ability to project will across space without degradation. They built a machine that compressed the world, turning a continent into a neighborhood. In our era of fiber optics and algorithmic logistics, we are still merely iterating on the blueprint they laid down in the dust of the steppe. The connectivity, maintained by rigorous protocol, is the ultimate competitive advantage.